Welcome to homework.
In problem 74, it states that a gun is shot 15 degrees north of west and 25 degrees upwards from the horizontal. And since we're looking at the recoil force, the force is going to be directed back towards where the gun shot from. And the recoil force is given to us as 400 newtons. In part A, we're asked to find the x, y, and z parts of the force. So to find the force in the x, it's going to be in the positive x direction. We take our resultant force, 400 newtons. We'll multiply it by the cosine of 25 degrees to get it into the xz plane. And then we'll multiply it by the cosine of 15 degrees to get it along the x-axis. And that comes out to 350 newtons. To find the force in the y direction, we simply multiply the resultant force, which is in the negative y direction, times the sine of the angle 25 degrees, which will give us the opposite side of the triangle that the resultant force and the 25-degree angle make, which is the y-axis part of the force. That comes out to 169 newtons in the negative y direction. The force in the z direction is positive, and we multiply it by the cosine of 25 degrees to get in the xz plane again. And then this time we take the sine of the 15-degree angle to get the z component, which comes out to 93.8 newtons. Now part B asks for the x, y, and z angles for this resultant force. We can use the formula where the cosine of the angle is equal to its component of the force, which in this case is the x direction, divided by the resultant force. And so we can plug in f of x, 350 newtons, over the resultant 400 newtons. Solving for theta, we get that it is equal to 28.9 degrees. We use the same formula for the other two angles. So plugging in our y component of the force over the resultant, we can solve for theta sub y, which is equal to 115 degrees. We use the same formula for theta in the z direction. We get that this last angle is equal to 76.4 degrees.